So, hi everybody. My name is Stefano Gridelli, and I'm co-founder and CEO of NetBeez. In this session, we'll go through a live demo of NetBeez to show you an overview of the dashboard, features, and then some troubleshooting and some integrations also, like including Slack. Okay. So, how many of you, first of all, are familiar with the NetBeez here in this room? Have tried a little, like Brandon, nobody else? So kind of like a first, I would say, deep dive into NetBeez. I'll start from the beginning. Okay. Okay, so as you see, I'm logging in now inside the NetBeez dashboard. This is hosted in the cloud. As Panos was saying, the dashboard can be hosted on premises or by us. If it's on premises, you will receive an OVA. It's pre-configured. You load it on VMware, vSphere, and you're set to go. You plug the agents, and everything is good. Before maybe I'll talk about the dashboard, the agents, we have like three types of agents. We have the fast Ethernet. This is the one based on Raspberry Pi. You plug it on the switch, and you're pretty much done. This is the wireless one. Is the ACE agent, the new one that we just released. Can be dual mode. And the third one, if you want to push more traffic with the iPerf, it's a gigi one. Can push up to 650 megabit per second. Or sometimes if you have maybe a router that only supports 100 megabit per second, this is the way to go. Because the Raspberry Pi is 10100. So we had some customers that just have a SFP. Okay, so as you first log in, and this is the new bus tab, as we call it, the new view introduced after NFD 9. This is where you see, it's like a NOC dashboard. You see all the alerts coming into the system. The alerts are, of course, generated by the server based on the data that the agents feed to the server. So as you can see here, we're having some performance issues happening. Most probably is the Pittsburgh office that is throwing a lot of packet loss. Lately, our network has not been so well performing. So let me explain you a little more what you see here. On the top one is all the alerts, right? We trigger alerts from ping, DNS, HTTP, and traceroute. And we have orange alerts, which are performance issues, and we have red alerts, which are failures. The orange alerts can be based on dynamic baseline. So we learn and compute a short-term average of packet loss, round-trip time, in the case for ping, same for DNS or HTTP. And then we compare that baseline with the long-term baseline, whether it's like 1 day or 1 month, because that should reflect the real average performance, right? It's based on a longer time period. So the beauty is that you don't really have to set specific threshold for the triggering. The system will automatically learn that performance, and then based on the rule that you set, will trigger alerts. So as you see now, there is a lot of going on. And there is also a real-time window. Like if you see top right there, you see like alerts coming in and then piling up on the last hour. So you see, hey, now we have a performance issue occurring. Especially for the most is on the network layer because it's ping. You see 128.
How are you learning that baseline again?
Yeah, so the baseline is a simple average in the end. So think about we continuously receive in real time a round-trip time from ping, for example, and then we compute averages.
And you have some sort of static, standard deviation that you've placed in there.
So right now it's not based on percentile; it's based on average.
Okay.
The percentile is another. I would say performance alert that we want to implement because it removes some noise, right?
Yeah.
Right.
And then exactly. What metrics are you gathering for HTTP?
So HTTP is query time for now. Okay. Just HTTP get. That's it.
Yeah.
It's like just good enough to say the network is good.
Yeah.
Our primary goal is not the network. Yeah. It's the application. If it's the network, then okay, we jump on it, right?
Any plans to add transaction support for HTTP?
Yeah, exactly. Yes, HTTP transactions, they're not super primary, but they're important. We understand because everybody's going to the cloud and they want to understand what is the performance to Salesforce or Microsoft Office. So yes, so we will.
Sweet.
Yeah. But yeah, the top of the line really were like mostly from our customer, like network issues. Like we want to know schedule test. We want to know like maybe they want to see more wireless features. So that's why we're prioritizing a little more that.
Yeah, makes sense.
Okay, so that's the baseline. Just a little like overview of the dashboard. We have different elements. We'll see now all the tabs that you can see NetBeez. But the bottom line is that you see on the bottom left the number of agents. This is a fairly small installation with 23 agents, of which one is down. On the bottom right, we have here we have also an integrated chat. If you want to talk with us, you have a problem, you want to give us feedback in real time, you can talk there.
Excuse me?
Yes?
The total alerts, the total doesn't add
Doesn't add up? So let me see, 142 plus 13, 152. We have one agent down, 156, plus another alert for a wireless down that is not there. So yeah, there is like a discrepancy because some alerts are not performance alerts. That's something that we have to...
So there is some issue?
No, there are not issues. Like there are two types of alerts that you didn't see here, which is the delta, correct?
Okay, yeah.
Right, one is a agent down, which is not displayed on this view. And another one is the wireless card down.
Okay.
That is not, it's actually displayed here. If you scroll down, yeah, this is an old alert. There you go. Those two alerts, they're not accounted.
Okay.
That's why, yeah. Okay, moving next, agents. This is like the agent view. And we have like the thumbnail or the inventory, just to quickly show you. Let's go with the thumbnail. The thumbnail gives you like at a glance the status of your network. And as you see, a lot of performance issues we also have grouping, are from our NetBeez office in Pittsburgh. That's where you see most of the performance issues. So you can see from the icon what type of agents you have. The little plug is the Raspberry Pi, the fast Ethernet version. You have the Gigabit Ethernet, which is the G on the Pittsburgh lab. Then we have the wireless one in blue. We have the two virtual ones. There are vSphere OVA images. There are the external one, the Cloud Amazon and Cloud Google. Yep. And then I think that's pretty much it. If an agent is down, like the one in Allegheny Wi-Fi, you see red. And as Panos was saying, and you were asking, now if that agent is still actually up on the network, is still running tests and caching locally the data, then when it will reconnect back to the dashboard, we'll send back the test. So the beauty is that should the data center go down or reachability be lost between the agent and the server, you will still gather that data.
I don't love this GUI.
Yeah, what do you...
That is
Busy.
a lot of
It's busy,
stuff.
yeah.
I don't want to see all the agents at once. I don't know. There's just a lot going on there, and it's not... Initially, it just kind of hits you in the face with all these numbers, and there's colors, and...
It's like, what is going on? Yes.
Yeah.
Is there a roll-up?
So look at this like as a drill down view. Like what we're gonna do, like you have grouping and you have the primary dashboard, because right now there is a lot going on that location. So there is a lot of like performance issues. And they're all located, like we have 6 agents in one location throwing in a lot of alerts. So generally you should have 1 or 2 agents per location. So you'll see it's much more limited. But yeah, I mean, this is see as if you shouldn't use this too much. You should use more the bus tab. But this is a further drill down dashboard, right? When you really want to go drill down. Or another, which I'll go next, is the target view. Okay, but good point. I mean, we're looking actually in the future to kind of aggregate this information, right? And further layer. Like if you see initially NetBeez was just a grid view that we have, a bunch of tests. Now we're always extrapolating, like extracting information from the dashboard to give you simple information.
Can that roll up into sites? I mean, this view, can you...
Like have a map, perhaps?
Or group it.
Or group it.
Yes, you can group it.
Something smaller than that.
Yeah, so you can basically create your own groups and then group them based on whatever. This is the external agents. These are all the online ones. So,
but I want to see just the stats for the whole group in one
right,
thing.
yeah. So that's the one that we have to implement.
Yeah.
That is not implemented exactly. So you'll define groups, and then you extrapolate, say, number of alerts for that group.
Yeah.
Yeah,
Right.
I mean, if I had 500 bees,
Right.
this is going to get gross really quick.
Right, it is. But actually, that's why we say the bus stop is meant to be your view in the network. And that's the drill down per location view.
But if I had an application that had a problem and I had 500 bees,
Right, so you go,
this alarm thing is going to go crazy so fast I'm not going to be able to see it.
so you go on the target view, which is the next view.
Okay.
Okay, so the target view, at this point I'm going to skip it and then we're going to drill down. So the target view is, the target is the application that you monitor, right? And as you see here, we group applications based on what you're monitoring and the agents that are inside that application. So it's like a container of tests and agents. As you see in this case, we have like performance issues in all the applications because the common entity, I would say, is the agents, right? So you can see, like, for example, we're monitoring a generic cloud applications, the DNS servers, Google Apps, and so on. So from here, for example, if we take let's say this generic cloud application, right? Now I see, based on the test that I push to the agents to monitor that application, how many agents are having problem with HTTP or ping, okay? So let's take, for example, the case of HTTP. Actually here. Okay, so in the HTTP view, as you can see, there are like, all agents are doing fine, but there is like one agent, the Pittsburgh Wi-Fi, that is not able to reach the application. So this is like the aggregate view from all the agents about what's happening with this application. As you can see, we also added the aggregate performance. So that's the in average of response time to reach that application.
So you're testing HTTP you have Salesforce app there. What are you testing specifically?
It's an HTTP GET.
So you're doing a GET to just like Salesforce.com.
Right, it's not a transaction.
Yeah, because I mean, you're going to need to add transactions because the main webpage of Salesforce.com means nothing to a Salesforce user because once they log in, they get sent to their shard.
Yes.
And the main page means nothing anymore.
It's a front end, yes.
Yeah, so
exactly.
I mean,
so our goal is like to make sure that the application is up, running, and that's all we care for now.
Yeah, but that doesn't tell me that Salesforce is up.
Right.
It tells me the login page is up if my shard is down.
Exactly.
Right?
So in this case, I put a Salesforce up. It doesn't mean that I'm monitoring the application. I'm monitoring the front end.
Right.
Right, exactly. So I could have named it, I don't know, Microsoft, but I'm just making sure that Microsoft.com or Office is up and running, and that's all we care. It's not like too much the application drill down in the transaction. Right. So from here, I can drill down. So I can see for each individual agent, I can do a comparison in real time about what is the HTTP GET, for example, between Athens and Allegheny, right? And so I can see already difference in real time in HTTP GET time. Again, it's not telling me about the transaction, but it's telling me about the different locations. Okay. So going back to create a test or a group of targets is very simple. You click on the plus sign here. And for example, let's imagine we want to monitor the Tech Field Day website, for example, to make sure that we can have layer 3 connectivity, that we can resolve DNS, and that the HTTP front end is running. So I name the Tech Field Day, for example, website. And what I do, I create a resource. So let's take, for example, an application that is done from a front end and a back end from an HTTP perspective. So what you want to do is you want to test maybe the front end and different backends. So you can create within the same target multiple resources. Or maybe a suite of applications like Google Docs have different URLs that your users have to reach. And so you will include maybe drive.google, mail.google, and so on. So that's the reason of having resources as part of a target. So I add the resource. In this case is techfieldday.com. Okay, whoop. All I need is to put the address, then the label is whatever label I want to put. And then I can enable ping, DNS, HTTP, and traceroute. Okay. So as you notice, what we care is that do we have layer 3 reachability? Can we resolve the URL? And is the front end up and running? That's all we care. Plus, we'll add traceroute information to know from an internal routing perspective if there is a problem. We can see from the traceroute information where the problem is from a hop. A little more advanced feature that we support in ping, for example, we can also enable TCP ping tests to see if certain ports are open or closed. And for each transaction, we, of course, record if we have a response, first of all. Otherwise, it would be a failure. And second, what is the response time? We can also specify for ping the MTU. If you want to do some MTU analysis of your links, typically is if you go through a VPN or encapsulated link, the MTU might change, or your ISP might change it. You want to verify that with the MTU packet, like what is a ICMP extended ping, right? So you can do that. And another thing, you can also attach a DHCP value on your traffic. So you can also see different ping tests based on different like MTU sizes and different like DHCP value, how the QS changes. This is pretty high frequency, like it's a 5 second by default. You can really go very frequent and you have quick detection based on the alerts. We keep the same like 5 seconds. DNS is pretty simple. We have a simple query. You can use the default DNS servers that the agents are configured with, or you can specify a specific DNS server. So that's very appropriate to monitor specific DNS servers and compare them. Like we have, for example, a DNS target where we add as resources multiple DNS, Verizon, Comcast, Google, OpenDNS, and then we can do comparison of performance. HTTP, again, it's a simple HTTP GET, no transactions. You can also use HTTPS, self-signed certificates, and column 8080 if you want to use non-custom ports.
Authentication?
Nope, no authentication. We just do a GET, yeah, very simple, yeah. Okay, by default we do every 60 seconds. Also here you can do 5 seconds, 10 seconds, whatever you prefer. The last is traceroute. You can do traceroute with UDP, ICMP, and TCP. On top of that, you can use advanced options such as port number, timeout, and DHCP value. So if you notice, what we're building here is like a Swiss Army knife. So we give you like the traditional commands that you run on a CLI and give you a distributed system where to push the command and get her back, right? So it's very kind of simple commands if you think, and nothing like crazy around ping, DNS, HTTP, or traceroute. But then we give you around the dashboard and the alert profiling and the historical data that you need, of course, to have some memory of your network. Kind of. So in this case, with the UDP SMP, we also do the path analysis, so the MTU. So we can also record the MTU of your path. Of course, it depends from the source interface. So if you have a 1500 bytes agent, that would be the maximum MTU that you can see. Okay, let's do ICMP, or let's do TCP. Okay, then the next step is configuring to what agents do I want to push these targets, these tests. I can either push it to all the agents, or I can push it to a group of agents, like the one in the NetBeez office, or just the wireless agents. Let's just select them all. And then the alert.
I'm sorry, if you already covered this. How do agents get into groups?
So right now, the grouping is just a UI. In the end, it's a way to, it's like a directory in the end.
You have to. I'm assuming the agents show up in some sort of uncategorized mode,
right?
And then are not part of any tests until
exactly
you move them in. Okay,
right.
The use case I'm thinking of is if, for instance, I had the NetBeez agent running as a Docker container in a Kubernetes cluster, for instance,
right.
And I wanted to just really make that test much more powerful. Set the replica to like 20. Of course, I'd naturally have enterprise licensing, and just sort of spin it up real quick and just bomb the hell out of maybe one of my web servers internally just to see how it works.
For automated
that's
testing.
sort of a showstopper if I have to do it manually.
Yeah, so that's a great thing, and we had the request that we want to implement, like automatically attach an agent to a group with some test definition.
Yeah, it's a tight balance with security though too, admittedly. So you have to be careful, I think, with that. But
yeah, I mean, we have. You mean if someone else?
you would need to make sure that your agents are authenticated, which I'm assuming you're doing in some form or
certificate.
fashion.
We do with a certificate.
Yeah, so
that's why the certificate makes sure that it's private. And if for some reason one of the agents get compromised and stolen, you can put on a blacklist.
Cool.
So that agent will not connect anymore.
Cool.
Right? Otherwise, yeah. So the automated testing, that's a great use case actually that you can use that. And as you were mentioning before, the APIs, that's something that we want to do for the next release.
Yeah.
Like we have actually API available, we just have to create the authentication method.
Right.
So then you can basically integrate with other third-party tools or your own development.
Cool.
Yep.
Just a question we've had online. So is there any plan to implement user scripts or wrappers within the agent that would allow authentication and response type verification?
For an HTTP transaction?
Yeah. Assuming that's what Jody's asking.
Right. That's so it's a great question because we've been thinking about almost an SDK of tests that you can push to the agent. Yeah, that's something that we're looking. Yeah. So not right now, unfortunately, but that would be the trick. Like you have basically the system and you push scripts and then you gather data back.
Yeah, and just some feedback on that too. I mean, if you're going to create a system like that, only because some of your users may not be awesome developers like Matt,
right?
Some kind of a interface within the GUI to create and say, I want to do this and do that, and then you guys sort of do the heavy lifting on the back end.
Like a WYSIWYG, record these HTTP transactions, create the test definition, push it to the agent.
Yeah, so that's the way some other products have done it, where I go and do something, and while it's watching me, and then it says, okay, I'll replicate that.
Yeah, absolutely. We're on the same page with that.
Cool.
Yep. Okay, good. So these are the agent selection. Again, you're flexible to choose whatever agents you want. The alert profiles, I can cover that later in the NetBeez settings. But you can create really any alert profile that you want and then attach it to your tests. The alert profile is in the end the rule. When it meets certain parameters, you trigger an alert. Kind of pretty simple. In the future, it would be nice you execute an action, right? So you can start automating things, hopefully. So right now we have the default rules, I think, up-down for ping, up-down for DNS, and up-down for HTTP and traceroute. So we don't have any performance alert right now.
So,
yeah.
The Raspberry Pi that you can buy from you guys, I'm assuming that we'd have root access to it, and you can really do whatever you want on that device.
Yeah.
So while you couldn't pipe the data into that portal, you can still do more advanced kind of troubleshooting manually.
Right. Yeah, exactly. We basically give you access as console access to the Raspberry Pi. You could SSH, but that's not very convenient maybe. Perhaps it's behind the firewall and you don't have the port open. And so you don't have to keep SSH open. So we give you a console integrated with NetBeez that you can use. And actually I'll show you in the agent detail view then.
So there's no way to get to a command line from that console?
From the dashboard, yes, you can.
Oh, you can? Okay.
But also from your own PuTTY, for example, you can do it if you open the SSH on the Raspberry Pi.
Gotcha.
Right. So we give you that access. Just the console is non-interactive, but batch mode. That means you cannot do VI or edit text files because you don't get the prompt.
Gotcha.
Yeah. Okay, and then actually I'll show you that back to the agent view. Okay, after I've selected the alerts, the last thing is do you want to send in emails for alerts, or then we'll show you the integration with SNMP, Syslog, and Splunk. You'll do it on another panel, on the NetBeez settings in the end. Okay, let's disable email alerts for now. Click Save, and now a new target is created, and the tests are pushing real time to the agent. Boom, that's pretty much it. Yep. And now these guys will keep pinging, and you see already they're adjusting their performance. You can see from all this location what is their network experience in the end, packet loss, and round trip time. And what we always notice, we have agents like in Europe, and you see always from Europe you have an average of 160 milliseconds, and from US about 50 milliseconds. So that's some cool stuff. Okay, so this is the target view. Again, you can basically, you have those bricks and you can build whatever target you want. It's a web service, it's a DNS, it's a maybe full mesh of ping tests to check end-to-end latency on your network. I would go back to the agent view since we skipped that a little to give you some details.
Yeah, I have a quick question.
Yeah.
So on the targets, did you apply those to agents in that screen? I missed that part.
Yeah, so when I created the tech field day here,
Yes.
I basically selected the tests, ping, DNS, HTTP, and traceroute, and then I selected the agents that you see here.
Oh, the agents were those on the right. Okay.
Right.
Thank you.
Yeah. And then you can also drill down. Now, of course, we're waiting for data. But then if we see an existing, let's see, Google, for example. Like, everybody does Google, of course, because it's I would call it the internet loopback, I call it, because if you can reach Google, you're good. So as you see, so the HTTP, this is the average performance. Then you can click at one point in time and see how the performance distribution is distributed across your locations. So you see 13 agents between 0.1 and 0.2. Again, this is a simple HTTP GET. And this is for ping. OK. Now, going back to the agent view, let me show you. This is a regular fast Ethernet based on Raspberry Pi. You see we give you some statistics like the availability, the agent uptime, for example. We give you the IP interface. All the configuration of the agent is done from the user interface. So what does that mean? That when you receive a NetBeez agent, you plug it on a DHCP VLAN, it gets an address and then reports back to your server instance. So you don't have to do anything. And then if you want to set a static, you can do so from the interface management. You can basically set everything. Now, here you can also see from that location what is the ping time to all the targets that that agent is part of, including DNS, HTTP, and so on. There you go. And then you can also check if that agent, of course, for each object, whether it's a target or an agent, we can filter all the alerts triggered by that specific object. So in this case, we had some failures with the agent that went down or some performance issues, Salesforce, and so on. But this is more on the network side, if you notice, because it's packet loss on ping.
Stefano?
Yeah.
So I know you said that there's some new tests that you guys added, like speed. Are you going to show us speed?
Yeah, I will show that. Yeah.
And then iPerf, you can iPerf between them too, right?
Right. Yeah. I'll show you the new scheduled test. Right. Okay. Yeah, absolutely. It's actually on the test tab.
Okay.
Almost there. So this is the agent console that you were asking about. So here you can basically execute a command like arp-a. You can see all the arp entry on the location. There is not too much. But you can execute nmap, whatever. You can also actually mod probe an IPv6 interface, the IPv6 module, and do some IPv6 testing from that agent, since it's not yet integrated on the dashboard. So really, you can do anything you want from the console. The beauty is that if you don't have access to the network, you have a CLI available to do some troubleshooting, bottom line. OK, the wireless agent, let's take this. Yeah, it's fine. OK, so this is the wireless agent. It's the same. It executes the same tests as a wired agent, as a cloud agent. So that's common abroad, all the type of agents. But on top, what we give you is the view of the wireless network. Now, this agent is doing pretty well because it's very close to the access point. You see that the link quality is a stable 100%. And these are values that we gather from the network interface card. So we get the link quality, the signal strength in dBm, and then, of course, the bit rate that is established with the access point. On top of that, we give you information about the channel and the BSSID. So you can basically see to what access point that agent is connected to and what is the channel that is connected to. Of course, it's a dual mode agent, so you can actually force it to connect to a specific channel, BSSID, or band. So that's very useful when you have a lot of agents and a lot of access points, and you want to monitor individual access points or troubleshoot ad hoc one specific issue. Okay. We also provide the historical information about the agent, about the wireless signal. Of course, it's a little busy, so you have to focus on specific part of the day. But the bottom line is also that is a metric that you can always keep in your data storage. You can keep it as a raw data type of test for 6 months, 1 year, whatever you think is useful to you. And with the calendar function, you can always go back and see what was the signal level yesterday, right? Because oftentimes, I don't know you, but I was troubleshooting problems that happened yesterday or 2 days ago, and then you don't have the data to say it was not the network or it was the network. So that's the beauty of historical data. Another feature is like available SSID, so you can do a site survey. Maybe on this agent we don't have a lot of SSID. Let's see this one in Pittsburgh. So we refresh the list, and now you can do a scan of all the networks broadcasting on that specific location. It's a dual mode, so you will see basically 2.4 and 5 gigahertz. There you go. Then you can, of course, sort it by signal strength. You can sort it by link quality, and so on. Again, this is another great feature to continuously scan the networks, see, maybe do rogue access point detection, maybe do some alerting in the future about when the signal is going below a certain threshold.
One little thing I missed.
Yeah, absolutely.
That is from the
agent.
The Pi.
Yep. Yeah.
From the Pi, you pop in the wireless module. Is it a specific wireless module, or is there a list of compatible ones?
Right. So we also give a list of compatibles, but with us, when you get a subscription, we give you also the hardware. So you just receive the hardware and you plug it in. But yeah, we basically use, as Panos was saying, a Asus AC56, and so that's what we support. But then we have a list of compatible modules. So everybody, you can use your own Raspberry Pi with the module.
Yep.
Yeah. Okay. Very well. So I think I give enough information about the wireless agents. The next is the tests. We're almost at the scheduled test with hyperspeed test and VoIP. Before this is the grid view, right? So we give you a grid view per each type of test. This was like NetBeez version 0, right? So we started with this and think about it, and then we build the agents, then we build the targets, and then we'll go always up the kind of information pyramid. But the bottom line is that here you can see a heat map, and you can see already like, hey, it looks like a network issue because I have, on the first column I have the agents, and on the first row the destinations. So it's very simple, intuitive, because if I have a band and it's related to the agents, clearly it's a network problem. While if I have a column associated to the target, the destination, clearly I have an application issue. So this is the information that we need quick to understand, do fault isolation in the end, right? Network or application, boom. And then I can move to the next step in the troubleshooting. We do that for each type of test. And also, the good thing is also here, if you want to open multiple real-time graphs, you can do so, and you have a place where do comparison in the end.
Yeah, this correlation is really nice. Being able to see that view, that's pretty unique.
Exactly. And actually, I see a lot of other, of course, dashboard implementing the same visualization. Mm-hmm. I see also, I don't know, like big data center, like Microsoft had Ping Mesh. They call it Ping Mesh, and they actually provide the same view where they can see clusters of data centers, and they can correlate visually that way. Yeah. So we, of course, don't use it too much right now, but still is like pretty effective, because then it doesn't scale the problem. When you have hundreds of thousands then of agents, you need to see the group view.
Right.
Right. Okay.
Is there any chance that the testing could be extended, like someone in the community writes a test and wants to share it, and then you choose to install it and have it show up here?
SDK, right? Like kind of share the test definition. You mean like gather information from your dashboard to my dashboard? Or you're saying the test definition?
Here's what I'm thinking is, with a Wi-Fi pineapple. Seen that, right?
Yeah, right. Yep.
There's that dashboard where you can install things that other people wrote.
Yes.
And you can run those tests, but it's not really, they don't tie into any other tests, right? It's just that you install it, you run the test, you're done.
Other monitoring tools have various modules you can add in. The community can build them.
Right.
They're all dropped on GitHub now. And then you can just pick and choose, oh yeah, there's this specific Cisco plugin that I want to use for my deal and just drop it in there.
Yes.
Yeah.
So
that would be cool.
Custom command. So we want to do that. So what you do is like either it could be initially a regex or a CLI bash, and then you upload the script on the Raspberry Pi. So this is not like the HTTP transaction that he was saying, but it's like someone wrote like the YouTube download command line command. So you could do that and then pipe it and get out the metric that you want to monitor.
Yeah, well, and I mean, you could turn the whole thing into an app platform, right?
Right,
So
exactly. Right.
Make a store out of it. People could
Yes, upload
sell
whatever.
this, you know, I need this and it does what I want and there's the price.
Exactly. Yeah, or even open. Yeah, either or.
Or
then there
free.
will be vendors or contributors, right? Yeah, the important exactly. We want to give the platform for this to happen, right? So we're getting there. We're building the kind of distributed platform, and then you can feed in all the plugins, measurement that you want, and then also eventually also like the alerts could be open. Like you can write your own alert profiles, right? So exactly.
It's really important to get those fundamentals right first before you open the floodgates.
Exactly. That's why we're doing first closed. It's really closed. We do ourselves because there is a lot of work in the back end and the end to do where maybe you didn't see benefits of HTTP transactions because we have other problems that we have first to solve in the development phase, right? And then we can open it. Yeah. So that's the goal. Also the API, same deal. We have to make sure that we're very solid on the server to open that.
Yeah.
Okay. Moving forward with the grid views. Let's close this. So, okay, traceroute, same deal. Okay, iPerf. So this is the new thing. iPerf, before you could run ad hoc iPerf, you specify the source and the destination agent. You can already do so. But now you can really build the iPerf schedule test. And that was a huge customer request. Every customer that we were doing a demo of NetBeez, they would always ask, okay, can you schedule the test? So finally we did it. And what you can do, for example, this is a TCP-based iPerf test between a wired and a wireless agent in the same office. So we can see how much, this is an ABGN adapter, I think, how much you can push through an ABGN between a wired and a wireless. And in a simple way, TCP iPerf gives you the version 2 only bandwidth. So you can see like the historical. Here we did an iPerf from every day, every hour, at the minute 12, 32, and 52, right? So we execute an iPerf for 10 seconds. And you can see, well, there is not too much to compare because it's between only two agents. Then I'll show you between multiple agents, you can see the comparison. But the beauty is that really you can see the historical performance between these two agents, source and destination. Here we have an iPerf between a virtual agent and a Gigi agent. Here the bottleneck is the virtual because it's on a vSphere that has a 10100 card, but you see that overall, the average is 94 megabit per second. You see the execution. Then this one is it's a UDP test between a wired and a wireless agent in the same office location. Again, these are like some templates of tests, but you can do much more between different locations. Right now, it's like one-to-one. It's not like many-to-many because there is a lot of scheduling on the back end. So what you would have to do is build multiple tests right now. But at least you can see on a scheduled basis the bandwidth, the jitter, the packet loss of all these iPerf tests. Now, the way like you create an iPerf test is very simple. You click plus, you name the target, you select one-to-one, and you select the source and destination agent. Or you can do multiple agents to one destination server. So you can select all the agents and then the server, and then you push the test configuration. We don't have here like a server open, but you can do so. So with the speed test, it's very useful if you want to understand what is the average download and upload speed of all your sites. That's one of the many information that you need to have to support your users and to troubleshoot, suppose, network problems. Oftentimes our customer tell us, yeah, the CEO has run a speed test and he complains about the network, and I don't know how to prove that it's not the network, or maybe it's the network. So that's a way, for example, to kind of verify the information, the actual speed. So if I click, for example, this is a speed test that I pushed to multiple agents. As you see, for this specific instance of speed test, I see the download and upload. That's the aggregate, the one that you see on the top. The average. So the average is about 30 megabit per second down and 7.50 up with a 40 second of latency. And then I can see broken down which one are the top performing, like the one in Allegheny, and the not so good performing, like the one in Paris. So the beauty is that then you can drill down and see historically like what is the performance, right? Because the one on the top is the average download and upload speed. Then you see for that specific instance, and then you can see the historical for the individual agent to see how much, right, it deviates. So it's a good way to really enforce SLA with your ISP, basically. How many do you guys ever have at home run speed test? Do you see a lot of problems with download and upload speed? Is it something that you ever wonder, like to have maybe a Raspberry Pi home and doing this for you? Or
I wrote a PowerShell script to basically do the same thing. Just run an iPerf test, pipe it to a CSV, pull it into Excel, graph it. Basically a lot of work to do what you're doing right here, right in.
Yeah, there was also, and your example, someone else like wrote the same and then was tweeting, the download and upload speed if it was not meeting the SLA.
Yeah.
With I don't know, I can't remember the service provider, but yeah, it was interesting.
Yeah, I think they were using speed test CLI.
Yes.
Package. Yeah.
Which is the same one we use in the end.
Oh, okay.
Yeah.
So that was going to be my question.
Right. That's what we use. Yeah. Speed test CLI is they're on gate. Basically, you load it on the agent and boom. That's
so if there was a speed test issue, like a deviation from what the normal is or something like that, you could alert on that in various ways?
Right. So right now we don't have alerts on the scheduled tests, only on the high frequency test, as we call them. Yeah.
Yeah, because it'd be cool if I could get an alert that says, the normal speed test we see is something like this. Right now we're seeing that.
Exactly.
And send it to Slack or email or whatever.
Exactly. So that's something
Tweet it to your ISP automatically.
Tweet it to my ISP, yeah.
Tweet it to my ISP,
Yay.
yeah. The action is
That's
right.
what we want to do.
The action would be a module that you can,
open a ticket automatically.
Right, even better. I wonder if there are APIs to open tickets. I was wondering. That would be amazing. Okay.
If I can do speed tests remotely, okay.
Yeah.
What about remote packet capture? Question came in.
We don't do packet capture, at least at the moment. Yeah. We do not do packet capture. Yeah, it's something that we're looking at. It's not priority based on but it's something,
Well, so you do allow remote access, right?
Yes,
This isn't
you
a
could.
supported NetBeez blessed thing,
yes.
but in theory, if someone were to, accidentally log in.
TCP dump, you can do it. You can do it.
TCP dump.
Yeah, I could sit and run a TCP dump. I could get a PCAP, pull up the box.
And then,
There's nothing integrated into the GUI.
Right. But you can do it through the command line.
Have you done TCP dump on a Pi, though? That might be kind of painful.
Right. Yeah, so there are actually other companies that we were talking about to integrate as part of the integration. So we could start with an integration, for example, so you can.
Interesting question. If I had, you had your HCL hardware compatibility list on there before.
Yes.
If I picked a new one up that you didn't have on that list, what does that support look like?
As long as it's Linux and the software agent works, we're good.
So I can still call and
yeah, exactly. Sweet. So we're really it's Linux in the end, right? So apt-get install NetBeez Agent, and then maybe some things may not work, but we use common, packages.
Yeah.
The only thing is really the wireless card, and Pano knows more about that. Is each wireless card gives you different information, so that may be something that it would be also nice to open a little more okay, you can support your own hardware. Here is the integration with the software agent eventually.
Sure. Yeah.
Another thing we're looking for is 10 gig packet generators, to also run Hyperf with 10 gig. That would be nice, but yeah, one thing at a time. Okay, so this is speed test. The last one is VoIP. So this is again a simple between Pittsburgh and San Jose office. As you see, basically we simulate a voice or IP traffic at the UDP level. There is no codec inside, just UDP packets. The timing and the size are based on the G711, G729 specifications, nothing new. And then you decide how often to run this, VoIP MOS estimates, and we give you the MOS score. And then, of course, other things like jitter and packet loss. So as you can see, it's basically like periodic. And the beauty of this is like you can really do from location to location. It's not just like, maybe other solutions are more like branch office to data center because that's where is the receiver. But with distributed network monitoring, you can really do location to location, so it's much more convenient. Okay, we're about. Okay, the other thing is like there are ad hoc testing. If you want to launch ad hoc test, you can do so. It's like almost having a GUI CLI command to run on demand when you need ping, DNS, HTTP, traceroute, hyperv. Then the reporting. You can generate reports. Right now are fairly simple. You can see, I don't know, the Google apps. So let's take Google. Interval average. Now let's do global average first for the last month. Let's generate a report for the last month, the average end-to-end round trip time to google.com. There you go, and then I can order them by latency. You see some locations. This one have a higher latency, but overall there are about 28 milliseconds. And you can see also some locations like the Pittsburgh wireless have continuously packet loss. That's most probably because of a problem with the wireless. Same for DNS and HTTP. Another thing, like the interval average, you can see, for example, for the last 7 days, how the performance varies throughout the week, so we can plot that. Right now, they're mostly like target-centric. In the next releases, will be more agent-centric. Okay, I think that we're basically done with the demonstration. I have the last couple of things, maybe show you quickly the NetBeez settings and the Slack integration, if you want to see. The Slack integration allows you to receive alerts on a Slack channel and also to execute commands, push commands to the bees through your Slack channel. I can show you that if you're interested. Okay. First of all, how the Slack integration works, you go through the NetBeez settings, and here we have an integration, of course, panel, and that's where you can configure your integrations. Here we also have the SMTP or the SNMP or the syslog, settings. Also in this panel, you can set your wireless profiles for your network that then you push to your agents from the interface management. The data retention is here where it's configured, and we give you the estimated space in real time, so you know how much you have to allocate. And it's multi-user and multi-role. So let me log to our dev Slack now. Dev, NetBeez dev. Dev Slack. Okay. Okay, this is like a development instance of Slack that we use, of course, to do some cool testing. So first of all, one thing that I want to show you is like the alerts. So the alerts that you see here, okay, this is the alert stream from all the agents, right? Then can be filtered on the bus tab for the ones that are active or open, and then on per object basis. So if you are on an agent or target view, you can see alerts specific to that object. The same is in the Slack. For, as you see here, I have the stream of alerts received by the system. So the formatting of the alerts is very similar as you see on the dashboard. You can see that, for example, we have the Pittsburgh lab to netbeez.net. That's a performance issue on HTTP. So the wording is very similar. And then what you can do also, there is this bees, that is the Slack bot. So the bees is the one that interacts with the API of the server and pushes command to the agents. So what you can do is, for example, is like list agents. Bees. Okay, there you go. So these are the same agents that you saw on the dashboard. So we have different agents. We have a syntax, then the ID of the agent, the IP address, and the status of the agent.
And these tests are all ad hoc, right?
So this is just a list of agents. Yeah, there are ad hoc.
Yeah, I meant
yeah.
My brain is operating on a 10-second delay.
yeah, so there are ad hoc right now.
So that means those are accessible via the API at a minimum, right?
Yeah, exactly.
Okay, good.
And actually, yeah, the API are there. It's just the authentication that we have to build the authentication token or method. Yeah.
Cool.
So then you can do help, and you can see, okay, what commands are available for my bees. I'm here. There you go. Okay, so right now we can do ping, DNS, HTTP, and traceroute. You have to use the agent ID. Sometimes with the text, the name of the agent is kind of not the best. So we said, okay, let's use the ID. So we can say, okay, let's take, for example, the Jersey City agent, ping 73. What do we want to ping? Google, as always.
So 73 is the ID of the source agent.
If I'm correct, yes. Right, okay, there you go. Okay, I'll start pinging, and boom, there you go.
You say ping everybody?
No, so right now it's like on a per agent basis. So then in the future we want all agents ping, right? Push commands to all agents. But right now it's like one by one.
Yeah, it'd be cool if I could say,
specify the group, basically.
Everybody ping this, and then it just did it like once or twice, or did it 5 times, gave me the average for all of them, and it displays. I mean, yeah, it'd be kind of cool.
Yeah.
He gives you Slack integration, and you're not happy.
Actually, I like that it's speaking English to me. I might,
Maybe. So it's a first interaction, as always. We always do little, and then we expand based on your feedback. So that's a good point.
That's why we're here.
Right, exactly. So this is basically the Slack integration. It's also the alerts, for example. We understand they're not very clear, right? So we want like to abstract a little more the information that we gather from the system, especially for Slack. We would like to make it like an intelligent bot that can tell you, hey, your network is down because of this. I'm calling, whatever ISP, it supports you. So it's the first step towards that, vision, I would say. Okay, and I'm glad to see that everybody uses Slack here. I was kind of watching your screen before, and I see some people like doing Slack, so that's good. Okay.
You installed that integration from the NetBeez Dashboard? I didn't.
Yeah, so on the NetBeez Dashboard, and actually, what you need to integrations. So you have to go on the Slack and put the web URL with the key. And then on Slack, there is a set of action you have to do. Actually, I'm not sure what you have to do on Slack because it's my CTO that did it, but we'll set the instruction online, actually.
Yeah. I was, okay.
Yeah. But yeah, it's like a very simple procedure, I would say,
Yeah.
Same for with Splunk.
You mentioned early on that you could install an agent on a Linux machine.
Yes.
Any plans to make that formalized as an agent that you can install across multiple devices and can you run agents as a VM? I assume you can?
Yes, you can, yeah. So,
okay. So what about like other, like Windows or Android or?
So like endpoint, right?
Endpoint, yeah.
Yeah, endpoint. So right now our primary goal is not like to really monitor the end user, but monitor the network from the end user perspective. Because sure, it's great to capture the end user experience from the user endpoint, but we see right now is not our priority because we want something that is permanent on your infrastructure that you manage. It's a wide area network. And so basically no, bottom line, right now there is not a roadmap to do an endpoint monitoring. Because the bottom line is that we want to be more on the infrastructure side. The user might close the laptop, walk away, you might like have resources, competing for resources from other applications, RAM, CPU, memory. So what you're observing is really noisy based on what the user is doing.
Okay.
So, but nobody tells you not to run a VBox and load a NetBeez agent. Like, for example, I was testing some in-flight internet connectivity. So I had my VBox, right, with my NetBeez agent. I was seeing how much was the latency to planet Earth from the airplane. And it was like about 500 milliseconds. That tells me, you're using, maybe satellite. So you can still do that, but
what type of plane were you on?
Right, better not to say. Yeah.
The service was there.
Yeah, yeah. Or also other buses, so it was very interesting.